Good afternoon, everyone. We welcome you on this conference, part of the Grounding project, which is an exhibition and a conjoint public program that is situated in St. Petersburg, Russia. And this project is dedicated to the soils and their vital role in our lives and our society and their connection with technology. And this conference is called Ground of Care and Control. And through this play of words, we try to capture that the two possible modes of connection between technology and nature, in particular soils. From one side, it can be control, and in our time and present time, unfortunately, it is mostly control. Technology is aimed at controlling nature and extracting resources. And on this conference, we try to shift the viewpoint a bit and to speak of how technology can be careful to nature. And we call the scientists and engineers to this conference who work in this direction. And our first speaker will be Aleksandr Kapitonov, head of Robonomics company that works also in this direction. And so Aleksandr, we shift to you.
Thanks for the initial presentation and and the explanation of the science of this catchphrase, ground of care and control. In my presentation, I will try to show how we can really make the care from technologies, from technological side, about the nature, and what is the main goal of these changes, and how we go in this direction right now in our everyday life. I will show the simple examples about the scenarios that already exist in our rooms, in our flats, and this is a prototype how we caring about our home and how we can care about the ground, about the earth and the environment in common. Okay, let's go further. And short information about myself. My name is Aleksandr Kapitonov, and I'm a dean of the ICT faculty and associate professor at ITMO University. But from the other side, I'm co-founder of several companies. One of the main projects, it's Robonomics. It's a big network solution for making possible robot-to-robot and robot-to-human communication. And there is a lot of scenarios of implementation of that technology. And my position there called Robonomics Progressor. And who are able to read the fantastic tales from Strugatsky brothers, you should know this term, progressor. In the short explanation, it's a person who are able to push the civilization of different civilizations in other worlds forward and deliver the technologies and the pure thinking to this civilization, who are not so forward as the progressors civilization. That's why my position column like this, and I'm proud to be one of the progressor on the us. I'm also working a lot with robotics, as you can see, because I'm participating in the World Robot Olympiad, RoboCup competitions as a judge and the coach, and I'm working with robotics education, making robotics massive open online courses, and giving the lectures in these directions. So you can partially trust me. I'm trying to be on the top of the state of the technologies, and looking forward and trying to implement it on the real cases. Okay, and let's start from the one simple thought that robots are here. They already intruding in our life, and you are not see it, and maybe you don't think about the changing situation, but you're definitely looking at your phone, and the first example, the software robots that you are talking with, I mean, some bots inside the software, some algorithm that's giving you the information that you may be interested. And this is the first simple steps where you can face with the robots in everyday life. But it's not on right now. It's not only a virtual world that we are talking about. It's also here on the ground. And just let me show the several short video about the cases with robotics applications that's happening in different spheres. You can see the humanoid robots, the logistic robots, the flying robots, ground vehicles, automatic chairs. I think you will definitely see in the common future the autonomous driving cars, because it's really hot topics, and there is a lot of samples with the testing in USA, in Russia, in China. The most part of the technologically advanced countries pushing forward these ideas of autonomous driving. And you can see that the flying vehicles, water vehicles, underwater vehicles, they already can cover every part of the environment that's is necessary for watching, monitoring, and to get the information about it. This is the demo that give you the information that robots already conquesting a lot of spheres in our life. Maybe in some specific, of course, the industrial part, it's one of the biggest driver for robotics development and the system, autonomous system development. It's one of the forward things in this sphere, because lights out factories, the factories where people don't need to be as a machine making the single action, but rapidly and continuously day after day, because the massive production cycle, it's a bad place for people, but it's a good place for robots. Robots like simple actions that they can repeat, and there is not a big trouble for those machines. But let's try to come closer to our environment. I mean our home and flats. And here is the next idea. Look at this. Many of modern designs that's presented for your flat that designers propose to you, they already constructed with according the robotics existence inside. The simple first demo, it's a robot vacuum cleaner. To get access in every point on the in the room, you need to buy the chairs, tables, couch, and the sofa with a specific design that make possible to robot get under it and clean the surface. This is the simple example how the robot already influence on our life, everyday life. Just trust me, my flat it's already occupied and prepared for robotics existence inside, because it makes our life more simple, more soft. You are not spending time for routine tasks at home, as I don't know, dishwashing, cleaning, what else? Maybe heating and so on. And the next demo, it's the demo with the monitoring system, because right now on the market you can find a lot of examples, the monitoring system that allows you to control your house, control the humidity, temperature, heating inside, and so on. Here is a demo that some of those systems I install at my home, and can control the temperature inside without any additional actions. And in the together robotics and automation and the autonomous monitoring system, they gives you the new possibilities to interact with the environment and the surrounding world. This is the first demos for your flat, but those systems not only made not only for monitoring of your house or your flat, but also a lot of the system that makes you the monitoring of environmental things possible. And here is the several projects that creating of citizen science approach and delivering it with citizens observatories. When you're buying the sensor, installing the sensor in your house, on your ground, and it gives you the possibility to deliver the information about the state of the air, water, soil, and other environmental parameters to the common storage, and to make the analytics and propose some actions that needed to improve the state of the environment around. One of the first and the big it's project we observe that's giving the people possibility to install some sensors and deliver the information to the global storage, to the governance, and so on. Of course, Grow Observatory and the project that's much more closer to our topic that we are talking today, it's a Ground Truth. Ground Truth collect the environmental knowledge about the soil, about the state of the ground, how the ground is used, and so on. When the people participating in the crowdsource of the data, it's one of the good approach to create the global monitoring system and to make useful and efficient usage of the ground and the soil around. And of course, the project SAND, please, you can check it. It's the special solution with the software that install on your phone and making your phone at the sensor, and you're working with a mobile sensor, and you can deliver some specific data that when you need to measure in the specific place some parameters. Those solutions already exist. And one of the big projects in Russia that's called Brief Moscow, when the people placing outside on the window outside the flats the special sensors that's measuring the particles in the air, I mean the dust in the air, and humidity, temperature, and so on, and trying to monitor the different fronts of the air, polluted air and maybe dusty air, how it moves around the Moscow, and so on. And this is one of the approach that I previously told. When the crowdsourcing making the pressure on the governance and other participants who were able to improve the situation with the air or with the environment around, and crowdsourcing here is really good approach. We are also participating in this project and placing the several sensors in Tolyatti region. We are placing it on the billboards, because we found that the billboards, it's a really good place where you can put the sensor and you will have the electricity and the internet connection. That's why we use it. But let's go further and jumped to the last step of my talk, because I showed you that uh, in our life, in our everyday life, they influence our environment, on our thinking and the information. And after that, I'm talking that we already working on the creation of the big networks, independent networks for global monitoring, to understand how the environment reacts to our actions. If we are making these changes or this, how the nature will be after. And here is the last thing, last thought that I want to deliver you. If we have the possibility to make the monitoring and create the information about the real state of the environment independently, we can measure the negative externalities to the nature, how we influence on the nature, and how can we compensate it. And in this idea covers the approach when you're communicating in interacting with the nature, not as an object, but as an actor, when the nature also an actor in this system. Nature following some principles, and there is a lot of goals that should be made from the side of nature, and we can find the consensus in this thinking way, when the people acting with the nature and nature acting with the people, and we are measuring all the things and trying to find the equilibrium position for that. And here is one of the main projects that we creating for the ground control. It's related with the how to say, tokenization, or creating the obligations for farmers to follow some standards of the ground usage. Maybe you heard about the Paris Agreement about the carbon footprint. This big mechanism, big game, economical game, when you can compensate your CO2 footprint, and those money will be delivered to improve some, for example, electrical station in Africa that's working with the coal on the or oil to change it, replace it by the power, solar power, or water power, or wind power, some ecological approach to reduce the CO2 emission globally. You are not cutting your carbon footprint directly, but you are replacing your carbon footprint by reducing the footprint in other part of the world. And here in the platform that's called AgriData, we are making the same game. When the farmers taking the obligations to work with his soil, with his ground, in the specific way to deliver the nature goods and the soft exploitation of the ground and prove that they made all the steps, all the necessary actions for that they can reduce their costs. And just let me show how it's made. Just several information about the algorithm, how we did it. The farmer just creating the account on the platform and giving the information about the GPS coordinates of his field and how much how many square meters he has, what for it used. It can be for the animal growth, it can be for the farming, I mean the crops, and after that he delivered the information about the ownership and so on. Just let me jump to the step of the verification of the action of the farmer. As you can see, the farmer already delivered the map of his field, and right now we are getting the satellite screenshots or satellites photos and trying to understand how the farmer works with that field, what he did, what is the dynamic of the crops or dynamic of the usage. Here is it. Here is you can see the different parameters, how the field was used, what is the parameters of the coverage of the soil, and after that then the farmer proved all the action. He can sell the certificate, the green certificate, that he worked in the good natural way with that soil, and he got money for that from the global marketplace, as it did for the Paris Agreement with the CO2 emissions. This is the short explanation how the engineers approaching to the solution of the ground care and control, and I will be glad to answer any questions. My presentation is over. Thank you.
Thank you, Alexander. This is indeed a very interesting engineering approach, technological approach, and it seems quite effective. I think I have one question for you. What do you think are the main complexities at achieving this dream or aim of such nature as an actor? What are the main complexities on achieving it at scale, at Earth scale, at planetary scale, maybe even?
I think the main issue here, the point is when the nature acting, the nature or some natural situations, they are not cheating, and but from the people side it's not the same, and if the possible ways for cheating will be a lot, it will, the common game in that case will not work. It's the common rules for every game that we are creating. Economical game where a lot of cheaters, it's not working. This is the main issue, and I think the second thing what we should to do is delivering of natural thinking and approach when you are not interacting with the nature as an object, as nature it's our neighbor. We should very careful and understandable from our side to the side of our neighbor. And this is the good thing that we want to deliver to. Thank you for a question.
And maybe I have another moment to continue this line. So you're saying that nature becomes an actor, but after all, at some point, it is human who defines its interests. It's a programmer, an engineer, technological team who makes this solution. How do you think, how can we ensure that this process of defining interests of nature can be more faithful, more honest to nature?
I get the question, and it's a good point, because actually I told not about the that everybody delivering their goals and pushing forward some ideas as people did, but I told about the consensus, and the consensus state it's equilibrium position of maybe it can be some value of environmental parameters like temperature, humidity, and so on, that we are agreed that we see that the nature feeling really good with that parameters or another one, and we can find the consensus of coexistence, the people and the nature together, because actually we don't know the real state what it should be, because the wild nature it's another one thing. It's not it's prepared for the human existence, and the totally industrial city it's not preparing for the nature. And on the border of those different areas we should find the equilibrium position when the nature is feeling good and the human also possible to exist as a neighbor of the nature.
So thank you. This is indeed a rich answer, and thank you for the presentation. And I think we can switch to our next speaker, who is Maria Sviridova. She is an environmental engineer in the field of chemical environmental protection. Her artistic and scientific interests are in the area of cyclical processes, and it connects the local with the global, critically addressing the issues of datafication, surveillance, distributed networks and infrastructures, ecosystems, human and other relations, and so on. She has experience in urban wastewater treatment plants and incinerators, besides the previous points, and she will present a talk which is with an intriguing title, How to Fall in Love with Mud and Why Now is the Time for This. So Maria, please.
Thank you. Thank you for the previous speech. It's very interesting, and my speech is very little, but I think it's very emotional. And I think we can start. My name is Masha. I'm a research and artist, and it's very interesting because I'm investigating mood and decay. It's very important things in life. I think it's ground. I think it's ground. And firstly, let's figure out what is mud and where does the soil have to do with it. Mud is soil, loam, seal, or clay. mixes with water. It's usually from after rainfall or near water source. Mud can provide a home for numerous types of animals, including varieties of worms, frogs, snails, clams, and crayfish. Other animals such as hippopotamus, pig, water buffalo, and elephant. I think you don't eat. Bathe in mud in order to cool off and protect themselves from the sun. It's very important for animals' life because they don't have room. Submerged mud can be home to liver or various insects. And mud plays an important role in the marine ecosystem. Example, the activities of burrowing animals and fish have a dramatic chiming effect on muddy seabeds. This allows the exchange and cycling of oxygen, nutrients, and minerals between water and sediments. Mud can be called the fertile fertile in the ether, inhabit big countless bacteria and more. And surprising, when you're hearing the word bacteria, you probably think about illness, maybe probiotic food, and maybe about brushing your teeth. You probably don't think about electricity. As it turns out, bacteria can be used as source of electricity, and recent research has produced some surprising findings. It seems that bacteria have been plugged into each other all along, and this finding cloud open entirely new opportunities is bioenergy products. And about breathing metal. Derek Lovely, a person at University of Massachusetts and the head of the GeoBacteria project, found that some bacteria naturally produce electricity through their ability to breathe soil lumps of iron in the soil. We can harvest this electricity from the bacteria using device known as microbial fuel cells, MFCs. An MFC is made up of two electrodes, an anode and cathode, linked by an electrical connection. Bacteria breathe out electrons produced as part of the normal metabolism onto the anode. These electrons can be called as an electrical current. The electrons are then passed to the cathode to complete the electrical circle and create a kind of battery. Bacteria capable of producing electricity happen naturally in almost any type of mud, sewage or waste. The bacteria usually use this process to breathe without oxygen, turning this natural process into a function MFC. Is as simple as filling the MFC with mud, sewage or waste, and waiting for the bacteria. And next, I can talk about bacteria battery. What is this? The bacteria that can produce electricity do so by directly transferring electrons to the anode. Anode, it's negative. They do not use any intermediates or shuttles in effects. They reach out and touch the anode. And how MFC works. To do this, they have to produce some unique structure. Most notably, they produce filament that can directly transfer electrons in the way which metal does. Previously, scientists thought it was impossible for biological system to act like metal. Recent research with bacteria with sulfurandist has demonstrated that this filament called nanovirus act as tiny virus. Now it's very important. When the billions of bacteria that are growing together combine, the nanovirus join from conductive biofilms. This can transfer electron across considerable distance, opening up the possible of growing organic, self-repairing electrical conductors for use in biocomputers. MFC applications are currently limited due to the low power output. The most practical MFC currently in use by the United States Navy weighs 16 kilograms and produce the equivalent power of 16 diesel battery per year. It's very important problem with increasing the size of the device have currently limited generating more power from them. In many cases, the electricity produced by the MFC may not be its not important function. Science MFCs can convert organic waste into electricity. They are being investigated for use in bioremediation, where microorganisms are used to remove pollution. Often, the bacteria present in the ground can eat toxic compounds that might be present, but when there is nothing to accept the electrons produced, but the bacteria metabolism, it's slow down the degradation process. Placing an MFC in the ground speeds up the process, and while a small amount of effects may be produced enough, say to power flashing light, and it's very important, clean soil. I think you want to have soil without toxic chemicals is a lot of more valuable for scientists and other people. Next process, we can play it back forward. I think it's more important than create electricity with mud. And if you play it backward, MFCs can be run in reverse and used to produce organic compounds. Instead of consuming them, this process, called microbial electrosynthesis, was discovered less than years ago, I think. Humble dirt is the main ingredient in microbial fuel cells. Ashley Franks, a great advantage of microbial electrosynthesis is that the bacteria consume electricity and carbon dioxide and produce organic compound as waste. This organic compound can include butanol, a directly replacement for petrol or sugar. In other words, bacteria can be used to produce biofuels. When soil power is used as a power source, this process is identical to photosynthesis, but does not require the land and water used in traditional agriculture. A further advantage of microbial electrosynthesis is that fuels such as butanol. Butanol is very important. It's very important because it's a fuel. Can be directly used in our currently infrastructure without costly modification. This is not the case with ethanol. And next, making methane and electricity. One of the earliest source of bioenergy was the production of methane from organic waste. In this process, bacteria consume organic compounds and work together to produce methane. This methane can then be used for heating electrons, generation, and powering gas engines. It has been shown these bacteria are likely transferring electricity to one another while making methane. And knowing that electricity is involved in this process will allow design change and improvement, all which could make methane an important source for bioenergy in the future. That would make sense, given how much energy we are currently flushing down the toilet. And the end. Thank you for listening to the opportunity to reverse energy from the ground. It's very exciting, thank you. And pleasant to tell you about it here. Very important microbial fuel cells technology decides a very important question about the cyclic nature of process. On the slide are my contacts. You can always contact me and ask about new research or how to make your first mud battery. I will always share information about it. And I think now, and then we will watch the video and find out how everything works, how it works, and how it's looking. Thank you.
So the rollout has ended, and thank you, Maria, for the very curious and interesting talk about this positive technology. Okay, and then we switch to our next speaker. It is Andrei Lazukin, who is a postgraduate student of the Faculty of Biotechnologies at ITMO University. He was born in Krasnodar, and he graduated from the Faculty of Biology, and his scientific interests lie at the intersection of biology, chemistry, and physics. And during his studies, he participated in project shifts of the educational centers as a teacher, and worked at the Foundation for New Forms of Education Development as a federal tutor, and also participated in the Bacterial Internet project as a lead engineer. And in this talk, he will speak about this project and its basis of citizen science. And we can continue to its talk which was pre-recorded because of poor internet connection, but Andrei will be with us for the question after the talk. So we can proceed.
Hello, dear participants and listeners. I am Andrew Alexandrovich Lazukin, postgraduate student of the Faculty of Biotechnology at ITMO University, St. Petersburg, Russia. In today's lecture, I want to talk about the possibility of conducting scientific work with a positive effect for a wide range of people. Also, in the center of our lecture will the program of studying soil microorganisms, which is held at ITMO University and together with the student Kuban State University of Krasnodar. I think that the topic of popularization of science is in society is very important. Nevertheless, we need to understand how to get people interested to do science. I have been organizing scientific competitions for children in Russia for several years, and I was able to identify some patterns of the relationship between nature, society, and technology. So I believe that in order to popularize scientific knowledge, this concept should be taken into account. It is shown in the picture. These three parts here, and these parts are connected with each other and show us the peculiarities of the development of our society. No department can work separately from others. For example, the part nature contains the concept of value of some natural resources. Humanity must move from consumerism to science in order to protect the environment from depletion. This is very important and relevant in the present time. So in the humanity department, we must understand that civilization can develop only together with the development of the biosphere. Firstly, because the biosphere is a substance that surrounds and affects us. Secondly, we understand that humanity is also constantly transforming the biosphere, and this has an impact on our lives. And the third part, it is technologies. In this part, I should be noted that humanity cannot develop using only new physical laws or chemical laws or technologies achievements. So this we see that all the elements are interconnected. This means that for the comprehensive development of science, humanity, and nature, we need to take this concept into account. How can this be used? So I think that the concept of citizen science is best suited. First, citizen science is a scientific tool and helps to create new technologies. Secondly, it is a social tool and helps to develop a society. For example, children and students get the opportunity to feel like scientists. This can help to choose a future profession, for example. Three, the concept of citizen science works perfectly in the field of environmental research. Many people are concerned about environmental problems, and citizen science are motivated by helping to improve the environment with the help of new technologies. To develop this area, we have launched the Citizen Science Project, Internet of Bacteria. This project is aimed at developing the field of microbial electricity and microbial fuel cells. Microbial fuel cells is special biotechnological devices that allow produce electrical energy by the work of microorganisms. This is an environmentally friendly energy. In the future, this technology can be used to clean up the environment from waste, to restore the environment with parallel energy generation. However, at the moment, there are several problems for the development of this scientific direction. For example, low power microbial fuel cells. We are trying to solve this problem with the help of our project. So how do we do this? The basic idea to do search for new microorganisms that can generate more electricity. It is assumed that these microorganisms can be found in the soil. To test this hypothesis, we are asking a large number of volunteers to help in the search. To do this, we send special scientific kits for participants from different regions. We believe that by explaining the geography of the project, its participants have the opportunity to find something interesting. Participants receive a set of Internet of Bacteria name. This is also a microbial fuel cell in this kit. The participants place a soil sample in a microbial fuel cells and connects it to the internet. To do this, the set has a special device for transmitting scientific data. The participant begins to observe the work of the microbial fuel cell in the official website of the project in his personal account. The result of the work has the form of the electric power graph. If a participant registers in a high electrical power, we contact him. When, according to the results of the interview, the project participant sends a soil sample for genetic analysis of bacteria to Edmond University. At ITMO University, we conduct metagenomic analysis of bacteria, isolate clean kinds of bacteria, and confirm their high electrical power. In addition, we are engaged in bioinformatic search and determine which proteins are responsible for electrical activity. This will help in the future to create genetically modified bacteria for the biotechnological industry, energy, and ecology. In addition, if a new kind of bacteria is dissolved, the participant gets the opportunity to come up with a name for the new organism. He also becomes co-author of the scientific publication. Maybe now we have interesting what is including in the kit what we send to citizen science. Firstly, it is for microbial fuel cells without a membrane. Microbial fuel cells number 1 and number 2 are connected to a special device. This device measures the temperature and the voltage of the microbial fuel cells and sends this data to the Internet of and the official website Internet of Bacteria of the project and the personal account of the participant. This is due by the ESP8266 microcontroller and the analog to digital converter. So these microbial fuel cells are also connected to resistor of 1000 ohm. This the current goes under a load and we can calculate it according to Ohm's law. Microbial fuel cells number 3 and number 4 working without resistor. We made this concept specially so that we could compare the activity of bacteria in the soil on electrodes under current and without electric current. So besides, we use a control soil so that we can compare the activity of soil bacteria in the soil sample in the control sample. We send the control soil in a set and it is a sample for the participant. In addition, kits contain chemical reagents for chemical tests, such as soil activity, soil respirations. Participants also receive strips of cotton cloth to find out the activity of soil bacteria. Also, participants receive plant seeds for conducting a test with plants. In this picture, you can see the result of the destruction of cotton strip in microbial fuel cells. The sample was treated with nigidrine and it shows the amino acid of bacteria. Which this experiment we confirm that the bacteria in the soil are alive. This is very important for understanding the place of electrochemical reactions in microbial fuel cells. In this about what the whole set looks like. White bags are microbial fuel cells. As you can see, there are many different components in this kit. To assemble these kits, we attracted the forces of the students of my faculty. In such as auditorium, we were completed sets. Later, the kits were sent separately by cargo mail to different cities of Russia and different regions. So look at how many of them there are now. However, we are sure that there will be more in the future. And this is how participants work with sets. The main participants are children and university students. After connecting the device to the internet, participants will receive the graphs. The red graphs is the voltage in millivolts of the soil sample. The green graphs, it is the voltage of the control soil, and we also studying the temperature in automatic mode. For example, these are citizen scientists from the city of Orenburg. All this data is sent to database. For example, where we can see the current data. Already now we have an interest in some participants where bacteria generate a large amount of energy. It can be noted that the participants have a high interest in the project. We often receive positive feedback from teachers and children. In the Telegram channel, the discussions of the results for each country. Many children were able to get better acquainted with the ecology of their region. Also, many children got acquainted with complex structure of the soil or microbiome. The Internet of Bacteria project has a positive impact on the development of society, popularizes science, and allows you to study all the nature of your region. The project includes members of an international team of world-renowned researchers. At the moment, the project continues to develop successfully, and we invite everyone to cooperate. In the future, it is expected that the project will become international. The slides show my contacts. You can use the project website, Telegram channel, YouTube channel, my wiki, and my mail and my phone. Our team will be happy to collaborate with partners to expand the project around the world. Thank you all.
We thank Andrei for this very interesting and also curious project where citizen science can help to establish a new future of electricity. And let's together hope that all these technologies will get their development, and soon we will live in another world in consensus with nature. Thank you, everyone. Thank you, speakers. And goodbye.